Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of numerical problems on DC shunt motors. By solving these problems, we shall learn how to determine armature torque and shaft torque of a DC shunt motor. Let us first go through the equations we shall use today to solve the numerical problems. In a DC shunt motor, armature and field windings are connected in parallel across a DC source. The current flowing through the shunt field winding ISH equals to V by RSH, where V is the supply voltage and RSH is the resistance of the field winding. Applying Kirchhoff's current law at point A, we get expression for armature current IA equals to IL minus ISH, where IL is the current taken from the source. Supply voltage V equals to EB plus IARA plus twice VB, where RA is the resistance of the armature winding and VB is the brush contact voltage drop. From this expression we get back EMF EB equals to V minus IARA minus twice VB. When a motor rotates at a speed of n revolution per minute, we get expression for back EMF EB equals to phi ZNP divided by 60A, where phi is the useful flux per pole, Z is the number of armature conductors, P is the number of poles of the machine, and A is the number of parallel paths of the armature winding. Since for a particular machine Z, P and A are fixed, we can write EB equals to K phi N, where K equals to ZP divided by 60A is a constant. Input power P in equals to V into IL. Mechanical power developed in the armature PD equals to EB into IA. Output power or shaft power PO equals to PD minus PFR, where PFR is the iron and friction losses, or PO equals to P in minus PT, where PT is the total losses. PT equals to PC plus I square times RA, where PC is the constant losses. PC equals to PFR plus ISH square times RSH. Armature torque TD equals to PD divided by 2 pi N by 6T. Shaft torque TSH equals to PO divided by 2 pi N by 6T, where N is the motor speed in revolution per minute. In this problem, we have to calculate armature torque developed by a 440 volt DC shunt motor having armature resistance of 0.25 ohm and running at 750 rpm while taking armature current of 60 ampere. Let us first jot down the given data. Supply voltage V equals to 440 volts. Speed of the motor N equals to 750 rpm. Given armature resistance RA equals to 0.25 ohm. Armature current IA equals to 60 ampere. Neglecting brush contact voltage drops, we get expression for back EMF EB equals to V minus IA times RA. Using values, we get 440 minus 60 into 0.25, that gives us 425 volts. Power developed PD equals to EB into IA. Using values, we get 425 into 60, that gives us 25,500 watts. Let us now calculate armature torque. TD equals to PD divided by 2 pi n by 60. Using values, we get 25,500 divided by 2 pi into 750 by 60. That gives us 324.6761 Newton meter. A 230 volt 4-pole DC shunt motor has a 2-circuit armature winding with 500 conductors. The armature resistance is 0.25 ohm. The shunt field resistance is 125 ohm and the flux per pole is 0.02 Weber. Armature reaction is neglected. If the motor draws 14 ampere from the mains, we have to determine the speed and internal torque developed. Let us first write down the given data. Supply voltage V equals to 230 volts. Number of poles of the motor P equals to 4. Useful flux per pole phi equals to 0.02 Weber. Number of armature conductors Z equals to 500. Given armature resistance Ra equals to 0.25 ohm. Shunt field resistance RSH equals to 125 ohm. Line current IL equals to 14 ampere. Number of parallel paths A equals to 2. Let us now calculate shunt field current. ISH equals to V by RSH. Using values, we get 230 by 125, that is equal to 1.84 ampere. Armature current IA equals to IL minus ISH, that is equal to 14 minus 1.84, that gives us 12.16 ampere. Neglecting brush contact voltage drops, we get expression for back EMF EB equals to V minus IA times RA, that is equal to 230 minus 12.16 into 0.25, that gives us 226.96 volts. Power developed PD equals to EB into IA, that is equal to 226.96 into 12.16, that gives us 2759.8 watts. We know expression for back EMF EB equals to phi ZNP divided by 60A. Therefore, expression of speed N equals to 60A EB divided by phi ZP. Using values, we get 60 into 2 into 226.96 divided by 0.02 into 500 into 4, that gives us 680.88 RPM. Let us now calculate internal torque TD equals to PD divided by 2 pi n by 60. Using values, we get 2759.8 divided by 2 pi into 680.88 by 60. That gives us 38.706 Newton meter. A 6-pole lap-wound DC shunt motor has 500 armature conductors. The armature and shunt field resistances are 0.05 ohm and 25 ohm respectively. If the motor takes 120 ampere from 100 volt DC source, we have to calculate speed and armature torque of this motor. Given useful flux per pole is 0.02 Weber. Let us first write down the given data. Supply voltage V equals to 100 volts. Number of poles of the motor P equals to 6. Useful flux per pole phi equals to 0.02 Weber. Line current IL equals to 120 ampere. Number of armature conductors Z equals to 500. Given armature resistance Ra equals to 0.05 ohm. Shunt field resistance RSH equals to 25 ohm. For lap connected armature, number of parallel paths A equals to P, that is equal to 6 for this motor. Let us now calculate shunt field current. ISH equals to V by RSH. Using values we get 100 divided by 25, that is equal to 4 ampere. Armature current IA equals to IL minus ISH, that is equal to 120 minus 4, that gives us 116 ampere. Let us now calculate back EMF. EB equals to V minus IA times RA. Here we are neglecting brush contact voltage drops. Using values we get EB equals to 100 minus 116 into 0.05. That gives us 94.2 volts. Power developed PD equals to EB into IA, that is equal to 94.2 into 116, that gives us 10,927.2 watts. We know the expression for back EMF EB equals to phi ZNP divided by 60A. Therefore, expression for speed N equals to 60A EB divided by phi ZP, that is equal to 60 into 6 into 94.2 divided by 0.02 into 500 into 6, that gives us 565.2 RPM. Let us now calculate armature torque. TD equals to PD divided by 2 pi n by 60. Using values we get 10,927.2 divided by 2 pi into 565.2 by 60. That gives us 184.6197 Newton meter. The output of a DC shunt motor is 3.73 kilowatt while taking 50 ampere at 100 volt and running at 750 RPM. The armature resistance is 0.06 ohm and shunt field resistance is 50 ohm. We have to calculate iron and friction losses, armature torque and shaft torque of this motor. Let us first jot down the given data. Supply voltage V equals to 100 volts. Speed of the motor N equals to 750 rpm. Line current IL equals to 50 ampere. Given armature resistance RA equals to 0.06 ohm. Shunt field resistance RSH equals to 50 ohm. Output power PO equals to 3.73 kilowatt. Let us first calculate shunt field current. ISH equals to V by RSH. Using values, we get 100 divided by 50, that is equal to 2 ampere. Armature current IA equals to IL minus ISH, that is equal to 50 minus 2, that gives us 48 ampere. Input power Pin equals to V into IL. Using values, we get 100 into 50, that is equal to 5000 watts or 5 kilowatt. Neglecting brush contact voltage drops, we get expression for back EMF EB equals to V minus IA times RA. Using values, we get 100 minus 48 into 0.06, that is equal to 97.12 volts. Power developed PD equals to EB into IA, that is equal to 97.12 into 48, that gives us 4661.76 watts or 4.66176 kilowatt. Let us now calculate iron and friction losses. PFR equals to PD minus PO, that is equal to 4.66176 minus 3.73, that gives us 0.93176 kilowatt or 931.76 watts. Armature torque TD equals to PD divided by 2 pi N by 6T. Using values, we get 4.66176 into 10 to the power 3 divided by 2 pi into 750 by 60, that gives us 59.3554 Newton meter. Shaft torque TSH equals to PO divided by 2 pi N by 60. Using values, we get 3.73 into 10 to the power 3 divided by 2 pi into 750 by 60, that gives us 47.4918 Newton meter. A 10 bhp 230 volt DC shunt motor has an armature circuit resistance of 0.5 ohm and shunt field resistance of 115 ohm. At no load and rated voltage, the speed of the motor is 1200 rpm and the armature current is 2 ampere. If the load is applied, the speed drops to 1100 rpm. We have to determine the armature current, the line current, the armature torque and the shaft torque. Let us first jot down the given data. Supply voltage V equals to 230 volts. Output power PO equals to 10 bhp. Since 1 bhp equals to 746 watts, we get PO equals to 10 into 746, that is equal to 7460 watts. Armature resistance RA equals to 0.5 ohm. Shunt field resistance RSH equals to 115 ohm. Let us now calculate shunt field current. ISH equals to V by RSH, that is equal to 230 by 115, that gives us 2 ampere. At no load, armature current Ia0 equals to 2 ampere. Speed of the motor N0 equals to 1200 rpm. Line current IL0 equals to Ia0 plus ISH. Using values, we get 2 plus 2, that is equal to 4 ampere. Neglecting brush contact voltage drops, we get expression for back EMF EB0 equals to V minus Ia0 times RA. Using values, we get 230 minus 2 into 0.5, that is equal to 229 volts. Power input P in 0 equals to V into IL0. Using values, we get 230 into 4, that gives us 920 watts. Constant losses PC equals to P in 0 minus I0 squared times RA, that is equal to 920 minus 2 square into 0.5, that gives us 918 watts. Iron and friction losses PFR equals to PC minus ISH squared times RSH. Using values, we get 918 minus 2 square into 115, that gives us 458 watts. At full load condition, speed of the motor N equals to 1100 rpm. When field flux remains constant, back EMF EB is proportional to N. Therefore, EB by EB0 equals to N by N0. At full load condition, expression for back EMF will be EB equals to N by N0 into EB0. Using values, we get 1100 by 1200 into 229. That gives us 209.9167 volts. Again, back EMF EB equals to V minus Ia times RA. Here we are neglecting brush contact voltage drops. From this expression, we get expression for armature current Ia equals to V minus EB divided by RA. Using values, we get 230 minus 209.9167 divided by 0.5. That gives us 40.1667 ampere. Now we shall calculate line current. IL equals to Ia plus ISH. Using values, we get 40.1667 plus 2, that gives us 42.1667 ampere. At full load, supply voltage V equals to 230 volts. Speed of the motor N equals to 1100 rpm. Given armature resistance RA equals to 0.5 ohm. We have calculated back EMF EB equals to 209.9167 volts. Armature current IA equals to 40.1667 ampere. Line current IL equals to 42.1667 ampere. Constant losses PC equals to 918 watts. Iron and friction losses PFR equals to 458 watts. Let us now calculate power input. Pin equals to V into IL. Using values, we get 230 into 42.1667. That gives us 9698.34 watts. Power developed PD equals to EB into IA. That is equal to 209.9167 into 40.1667. That gives us 8431.66 watts. Total losses PT equals to PC plus I square times RA. Using values, we get 918 plus 40.1667 square into 0.5. That gives us 1724.68 watts. Power output PO equals to P in minus PT. That is equal to 9698.34 minus 1724.68. That gives us 7973.66 watt. Alternatively, power output PO equals to PD minus PFR. Using values, we get 8431.66 minus 458. That gives us 7973.66 watts. Let us now calculate armature torque. TD equals to PD divided by 2 pi n by 60. That is equal to 8431.66 divided by 2 pi into 1100 by 60. That gives us 73.1967 Newton meter. Expression for shaft torque TSH equals to PO divided by 2 pi n by 60. Using values, we get 7973.66 divided by 2 pi into 1100 by 60. That gives us 69.22 Newton meter. So today we have solved a couple of numerical problems on DC shunt motors. By solving these problems, we have learned how to determine armature torque and shaft torque of a DC shunt motor. Hope this lecture has been useful for you. If you have any suggestions or questions, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.